Welcome you all. In this session you are going to see the design of armature winding. The different armature coils in DC armature windings must be connected in series with each other by means of end connection in a manner so that the generated voltage of respective coils will aid each other in the production of terminal EMF of the winding. Two basic methods of making these end connections are Simplex lap winding and Simplex wave winding. First, let us discuss about Simplex lap winding. For Simplex lap winding, the commutator pitch YC is equal to 1 and coil span is almost equal to pole pitch. So here the commutator pitch is equal to 1 and pole pitch is equal to coil span, almost equal to coil span. Thus, at the end of any coil are brought out to adjacent commutator segment, and the result of this method of connection is that all the coils of armature in sequence with the last coil connected to the first coil, consequently closed circuit winding results. The name lap comes from the way in which successive coils overlap the preceding one. So this is the diagram, a circuitry representation of a lap winding. So the name comes, lap means one overlap another. So you can see if you take two segments of commutator AB, so each coil is connected to that corresponding commutator segments. Simplex wave winding. The second type is wave winding. For simplex wave winding, the commutator pitch is almost equal to 2. For lap winding, it is equal to 1 and here it is 2. Pole pitch and coil span is equal to pole pitch. Here the coil span and pole pitch both are equal. The result is that the coil under consecutive pole pairs will join together in series, thereby adding together their EMF. This winding is called wave winding because it appears wave at the end of connection. See, here you can see there is no overlapping. Instead of that you can see wave. So we call them as simplex wave winding. So let us discuss some topologies used. Back pitch YB. It is the distance measured in terms of armature conductors between two sides of a coil at the back of armature. It is denoted by YB. For example, if a coil is formed by connecting conductor 1 to conductor 1 2, that is one from upper conductor in a slot to bottom conductor of another slot at the back of armature, the back pitch is 12 minus 1, which is equal to 11 because 1 to 12. Therefore 12 minus 1, 11 conductors. Front pitch. It is the distance measured in terms of armature conductor between the coil sides attached to any one of commutator segment. It is noted by VF. For example, if coil side 12 and coil side 3 are connected to the same conductor segment, then the front pitch is 12 minus 3 and it is 9 conductor. Then the next one is a resultant pitch YR. It is the distance between the beginning of one coil and beginning of next coil to which it is connected. It is denoted by YR. Therefore, the resultant pitch is the algebraic sum of front and back pitch. Commutator pitch YC. It is the number of commutator segments spanned by each coil of armature winding. For simplex lap winding, the commutator pitch is equal to 1, and for wave winding the commutator pitch is almost equivalent to 2 pole pitch. Progressive winding. A progressive winding is one in which, as one strains through the winding, the connections to the commutator will progress around the machine in the same direction as being traced along the path of each individual coil. Note that YB is greater than YF, that is back pitch is greater than the front pitch, and YC, that is the commutator pitch, is plus 1. Regressive winding. Regressive winding is one in which, as one traces through the winding, the connection to the commutator will progress around the machine in opposite direction. Progressive means same direction, here in opposite direction to which is being traced along the path of individual coil. Thank you.